In this example, we have Sandra and Ted who are each able to produce tacos and beers. We assume here that Sandra can produce up to 15 tacos, or if instead she focuses on beer production, she can make up to 25 beers. Or she can make some combination of tacos and beers that's less than those two extremes. Ted can make up to 10 tacos, or he can make up to 5 beers, or some combination of less than 10 tacos and less than 5 beers. So we see right away that Sandra can make more of either. So she can make more tacos than Ted, 15 versus 10, and she can make more beers than Ted, 25 versus Ted's meager 5. So Sandra clearly has an absolute advantage in the production of tacos and the production of beers. She can make more than Ted. However, as we've learned, that does not mean that she will have a comparative advantage in both of those. So let's start out by determining who has a comparative advantage in tacos and who has a comparative advantage in beers. So comparative advantage is based on opportunity cost. So we will start by calculating the opportunity cost of tacos for each person and of beers for each person. So we'll start with Sandra, and then we'll look at Ted's. Okay, so starting with Sandra, we know that for every 15 tacos she makes, she gives up the opportunity to produce 25 beers. So the opportunity cost or marginal cost of one taco would be 5/3 of a beer, or 1 2/3 beer. Okay. In contrast, when we look at Sandra's opportunity cost of producing a beer, it's going to be the reciprocal of her opportunity cost of tacos. So for every 25 beers she produces, she gives up the opportunity to make 15 tacos. In other words, for every one beer, she gives up 3/5 of a taco. Right? So her marginal cost or opportunity cost of a beer is 3/5 of a taco. All right, now let's turn to Ted. So for Ted, every 10 tacos that he makes, he gives up the opportunity to make 5 beers. So per taco, he's giving up half a beer. In other words, his marginal cost of a taco or his opportunity cost of a taco is half a beer. In looking at Ted's opportunity cost of beer, we simply take the reciprocal of our previous calculation. So we would say for every 5 beers that Ted produces, he gives up the opportunity to make 10 tacos, or per beer, he gives up 2 tacos. Right, so Ted's opportunity cost or marginal cost of a beer is 2 tacos. So to answer the question of who has a comparative advantage in producing each item, let's take one item at a time. So in considering tacos, for Sandra, she gives up 1 2/3 beer per taco. Ted gives up less, only half a beer. So Ted has the comparative advantage in producing tacos. Okay, his marginal cost of making a taco is less than that for Sandra. Now, if we look at beer, for Sandra, one beer cost her 3/5 taco, while for Ted, it costs him 2 whole tacos to make a beer. So clearly, Sandra has a lower marginal or opportunity cost of making beer, and thus Sandra has the comparative advantage in producing beer, right? So comparative advantage So next we're going to draw the production possibility frontier for each of our producers and write out an equation describing that production possibility frontier. So let's start with Sandra. And I'm going to put beers on the x-axis and tacos on the y-axis, although it's perfectly correct to do it the other way around. For Sandra, she can produce at most 15 tacos, so we label that maximum here, and at most 25 beers, so we label that maximum on the x-axis. And we're going to connect those with our production possibility frontier. Now, turning this into a representative mathematical equation, we can say, all right, well, the most tacos Sandra can produce is 15. And then for every one beer she gives up, or every one beer she produces, she gives up the opportunity to make 3/5 of a taco, right? So again, this negative sign represents the trade-off between tacos and beer. And it's also the slope of our line, -3/5. All right, so now for Ted, we'll draw his production possibility frontier, and we'll keep beer on the x-axis and tacos on the y-axis for consistency and ease of comparison. The most tacos that Ted can make is 10, so we label that, and the most beers he can make is 5. And we connect the dots, writing out an equation that represents Ted's production possibility frontier. The maximum amount of tacos Ted can make is 10. And then for every beer he makes, he's going to give up the opportunity to make 2 tacos. So the slope of the line here is -2. Now we're going to draw a single aggregate production possibility frontier that treats Sandra and Ted as part of a single production facility or a single economy. So we're going to take both of these production possibility frontiers and we're going to basically stack them. So we'll do that on a new slide so that we have plenty of space. So on this new graph, we're going to have our x and y axes as before. We're going to keep beer on the x-axis, tacos on the y-axis, and we're going to first stack the flatter line, so the one with the flatter slope, which in this case is Sandra. Sandra's PPF has a slope of -3/5, while Ted's has a slope of -2. Ted's is steeper. So we're going to start with Sandra here at the top. So we start at the total maximum number of tacos that Sandra and Ted could produce if they both focus their production on tacos. So Sandra can make 15 and Ted can make 10. So together that's 25 tacos. All right, so that's a combination of Ted's 10 tacos. Okay, so this is Ted's 10 tacos plus Sandra's 15 tacos. Right, so we've just stacked what Ted can produce, 10 tacos, and then what Sandra can produce, 15 tacos, for a total of 25 tacos. Okay, so I'm going to actually draw Sandra's production possibility frontier. Okay, and then I'm going to stack it on top of Ted's, which remember is steeper. Okay, and right here is what we call the kink in the aggregate production possibility frontier. It's where the two connect. Right, so this first set of beers that are produced, this is Sandra's 25 beers that she can produce, and therefore this number is 25. And then Ted can make 5 beers, so we stack those for a maximum possible total of 30 beers. Right? So again, this is Sandra's production possibility frontier with a slope of -3/5. And this is Ted's production possibility frontier. With a slope of -2. Now notice the kink here. Again, this is the combination of 25 beers and 10 tacos. And if you recall earlier, we determined that Sandra has a comparative advantage in producing beers, and she can make up to 25 beers, while Ted has a comparative advantage in taco production, and he can make up to 10 tacos. So the kink of our aggregate production possibility frontier is actually the combination of output possible when both Sandra and Ted specialize in their comparative advantages. Our next task is a fun application of this aggregate production possibility frontier. So in part D of the question, we're asked, what is the maximum quantity of beer that can be produced if Ted and Sandra are producing 8 tacos combined? So we know that if we're trying to get the maximum out of our scarce resources, then we should have Ted and Sandra specialize in their comparative advantages. That means that whoever makes the 8 tacos should be the person that can do it most cheaply at the lowest opportunity cost or the lowest marginal cost. Right, so we've determined that Ted has a comparative advantage in taco production. So Ted should make the 8 tacos. Okay, and then once he's made the 8 tacos, he should devote the rest of his time to making beer, and Sandra should spend all her time making beer if the goal is to maximize beer production beyond those first 8 tacos. So we know that Sandra will make 25 beers. Okay, but how many beers can Ted make if he's already making 8 tacos? So for that, we actually want to go back to his production possibility frontier, which was this. And we can plug in 8 tacos for the T and then solve the equation to find out how many beers he can still be producing. So here we find that the total number of beers he can still produce while making 8 tacos is 1 beer. So if we add 1 beer from Ted plus the 25 beers that Sandra can make, we end up with 26 beers, which is the most possible number of beers that the two of them can produce if they must also make 8 tacos. For the final question, part E, we're asked to determine at what possible price would Ted and Sandra be willing to trade beers and tacos if they each specialized in their comparative advantages. So again, Sandra would be making beer, Ted would be making tacos, and assuming that Sandra doesn't want to drink all 25 of her beers and would like some tacos to soak up some of that booze, and assuming Ted would get really thirsty if he had lots of tacos but no beer, you know, that they would like to have some combination of beer and tacos. So we can ask, you know, what would be the trading price for 1 taco, for instance? In other words, what's the minimum price that Ted would accept? In this case, when we look back at the opportunity cost of a taco for Ted, we see that it's half a beer. So Ted would really want something more than half a beer for one of his tacos from Sandra. Okay, at the same time, we must consider what Sandra is willing to pay for a taco. What is the maximum price she's willing to pay? Well, if you look back at her opportunity cost of making 1 taco, if she were to make those tacos herself, then each of those costs are 1 2/3 beers. So that's the most she would be willing to pay to Ted for one of his tacos. So any number between a half beer per taco and 1 2/3 beers per taco would be an acceptable price that would make both Sandra and Ted better off, compared to a situation of autarky where they're not interacting with each other at all and just producing all of their own beer and tacos. So one example would be 1 taco equals 1 beer. Okay, but other combinations or other solutions are possible. So you could have 1 taco for 3/4 of a beer, for instance. If you like to look at it sort of in reverse, you could consider the price for 1 beer, right? So Sandra's producing the beers. So what is the minimum price she would accept from Ted for one of her beers? Well, if you go back and look at the opportunity cost of beer, for Sandra, each beer she makes costs her 3/5 of a taco. So as long as she can get more than 3/5 of a taco from Ted for one of her beers, she's going to be better off. But what is the maximum amount of tacos Ted is willing to pay for one of Sandra's beers? Well, again, if you go back and look at the opportunity cost of a beer for Ted, it's 2 tacos. So Ted is willing to pay up to 2 tacos for one of Sandra's beers. So any number between 3/5 and 2 is an acceptable trading price that will make both individuals better off relative to autarky. So again, here we see that 1 beer equals 1 taco. 1 taco is between 3/5 and 2, would be an acceptable trade. But there are, again, other possible solutions. You could have 1.5 tacos per beer, and that would make them both better off as well.